Computer vision, AI and robotics have been transforming a lot of industries. Mining industry has a lot of use cases for computer vision, robotics and AI. By applying computer vision, AI, robotics, we can improve the efficiency, the productivity of mines, make them safer, and overall improve the amount of production, improve how the mines operate. In this video, I'm going to apply and show you guys a use case of computer vision in mining industry, and this pertains to detecting people, workers in the mine. Now the question that arises is, what is the use case or what is the utility of being able to detect people in mines, detect mine workers? There are numerous uses for this. For example, number one is to know the number of people in the mine, number of active workers in the mine at any given point, so you can track and plan better. Secondly, you can get a sense of safety and security in the mine. It could be used for surveillance and security purposes. As an example, if you have a heavy machinery being operated and there shouldn't be any human being or mine worker in that area, with the use of computer vision, if you detect a person, a human in that area, you can detect and you can inform your operators, you can raise alarms, or you can shut the machine down to avoid catastrophic outcomes. Further, you could use computer vision to monitor if the workers are properly geared, they have the right amount of safety equipment, they are wearing their PPEs, they are wearing their helmets, they are wearing their gloves, and whatever equipment is required to make the environment safe and secure. Now for this particular demo, I used the Yolo v10 model. The Yolo v10 model came out recently. This came out in May of 2024. It is a part of the family of Yolo models. On the screen, you can see the Yolo v10 model. Now, this model, and this is the paper, this was released by Tsinghua University in China. And then this model is supposed to be better, faster, and better in performance as compared to the previous Yolo models, Yolo v9, v8, v7, etc, etc. So they have released the code for this. Here is the GitHub repository, and you can see that in this plot over here, it is supposed to be faster and it's supposed to have better performance as compared to all the other models. So this is the model we used. If you want to go into detail, you can check this paper out, and you can also check the repository out. We used the Yolo v10 model packaged in the Ultralytics toolbox for this demo. Now let's basically look at what the demo looks like, and let me show you first a sample output from one of our runs, just to give some motivation. So here you can see a mine scene, a mine scenario, and where two mine workers are working, and the model is able to detect those folks. One of the workers is the operator, the other is working on the machine, and you can see that the model is able to detect both. So guys, let's look at what the code looks like for this particular implementation. As I said, we are using the Yolo v10 model. We are using the nano version of model. There are numerous other versions available, large, extra large. They would improve the performance at the cost of the speed. Nano is supposed to be the fastest. And then here, it's pretty simple. We are importing the Yolo toolbox, and then we are loading the pre-trained weights for the Yolo v10 model. And then on third line, we are telling the model to do the tracking. And then this command basically is going to do object detection and tracking on top of your input. This is the source video. So we give it a source video, which is this video over here of the mine workers working on the machine and operating the machine. And then what we do is we give it the argument as show equals to true, which means that as the program is running, it will display the output to the user. The tracker we are using is ByTracker. So there are two trackers available. We are using ByTracker for this demo. Both of them are pretty good. So here we are telling the model to only detect the person class. There are a bunch of classes that the Yolo models detect, cars, airplanes, person, etc. But we are only telling it to focus on the person class. And then the save equals true is it will save the output video. So let's try and run this and see how it works. There we go. So this is going to run this particular script. So you can see that I have a virtual environment running, and then here is the output. You can see how it's able to run at 5 milliseconds. That's the speed of inference per frame. That's pretty fast, and you can see that it's able to detect all the workers. So now let me show you a few more examples. So here on the screen you can see a few more videos. This one we have already seen, and then over here you can see that the machine is operating, and then the workers come inside, come underneath the machine, and you can really detect. Now, one of the use cases that comes to mind is say that this machine is when it's running, if a worker comes underneath, or if a worker comes in an area that is unsafe, then you can trigger a fail safe. You can stop the machine, you can raise an alarm or something like that. So that is one of an obvious use case of this kind of solution. Another one, 2 mine workers are working, and we can see it's being detected. Here also there's a mine worker, and then there is a person driving this vehicle, and you can see both of them are being detected, and they are being tagged for the ID. So, and the ID stays consistent throughout mostly, which is again it is a testament to the tracker. Now guys, this was just a demo with off-the-shelf Yolo v10 models with the known weights, right, with pre-trained weights. We can further improve the performance. Again, this model has never seen mining data, or it hasn't been fine-tuned on the specific mining data that applies to this use case, and by fine-tuning on that data we can further improve the performance. The fine-tuning would involve taking the data, labeling it using any kind of labeling tool, RoboFlow, CVAT. There are a bunch of labeling tools, and then we can then use that labeled data to fine-tune the model to perform the tasks with a better accuracy. As such, we've seen the person detection at least is good. We can try other detections as well in here, but with fine-tuning we can even get better performance. That's it for this video, guys. In summary, we tried the Yolo v10 model. This is the newest in the family of Yolo models, and we tried it on mining data to see if it's able to work and see its performance. Overall, the performance is good. It's able to do the detections, it's able to detect people, and it's very fast as well. This with Yolo v10, if you're interested, you can check the GitHub repository for the Yolo v10 and go through the paper. If you like this video, please hit the like button, subscribe to the channel, and hit the bell icon so you are notified about any new video that we upload. Thanks again for watching, guys, and I'll see you in the next video.